Okay, check. Coming to you live and in recording. Pre-Calc 30, 11.1, this is our part 2. The other day, or the other lesson anyways, part 1, you went through a couple of examples. And 3, actually, examples. And today, I want to go through example 4, but before I do, page 522, you should turn there and you should read the worked example and sort of go along with it, follow it through. Make sure, well, it's an introduction, it's the same kind of reasoning you'd have for this problem that I'm going to work through, okay? Now, I'm going to assume that you've done the following. You're pausing right now, or you have paused, and you write out this problem in your notebook. How many ways can one French poster? This one, ABC. That's from page 522, the bottom of the page. Also, I'm assuming that you've read the permutations and constraints example above, and hopefully you're making some sense of it, and hopefully this will make a little more sense after you've worked this out with me. Okay, now, we're using the fundamental counting principle, the OR rule. And if you can do one thing and not the other, so you do one thing or the other, you add the possibilities. Remember the and was, if it's an and situation, you multiply them as a basic problem solving skill here. Okay. Let's read this situation and see. Now you've copied this into your book. I just put these symbols down here to help us interpret the problem a bit. For how many ways can one French poster, so I've got my little F here, 2 math posters, math 1, math 2, they're 2 math posters, 3 science posters, be arranged in a row on a wall if. Okay, we've got some scenarios here. The 2 math posters must be together on an and. Let's just think this through. Do you understand the problem, first of all? I'll do that now. So these math must be together here. So they could be on this end, either math 2 then math 1, or that order, right? Or they could be at the right-hand side. Now let's just think this through. The other posters, though, there's no restrictions on those. You can flip-flop, and those guys can trade. You know, French poster could be here, science 2, that poster could be here, and so on, okay? So the restriction is that the math posters together and on an and. Let's think this through as a case kind of thing. Either the 2 math posters are together, oh, I flipped accidentally here. Either the 2 math posters are together on the right or on the left. So let's just consider this. A. If they're together on left, we're talking math, or they're together on the right. There's other ways to solve this. I'm going to do it this way. Now let's think this through then. If I have 2 math posters on the left, and then 1, 2, 3, 4 posters there. Move the sideways a bit. Now, how many choices do I have for the first poster? I have 2. I can have math poster 1 or 2 times the second one. There's no choice for that. Then, for the next spot, I have all 4 of those posters to choose from. So times 4, 3, 2, 1. Or I could have the math posters together on the right. Now let's think this through. If they're on the right, well, first of all, the word or means add. If they're on the right, I could have the first 4 posters being the others, and then the last 2 posters are the math ones. Same reasoning as before, though. For the other posters, we have 4 times 3 times 2 times 1. By the way, the blue color of this marker here has nothing to do with it being a science or French poster. I just chose blue for a different color. And then for the math posters, there's 2 and 1. Okay, now it's the problem's solved, basically. You've got to just do some arithmetic. You could do this without your calculator. Try it. Pause it. Solve. Okay, you've solved it, I hope. 48 plus 48 is 96 ways to arrange the posters. And 6 ways to arrange the posters according to those conditions. How about B? 3 science posters must be together, but it doesn't say anything about an end. Oh, golly. Well, let's just consider this. It's problem B. We should treat the 3 science posters as if they're a group, like we did with the math posters, right? Now this time I'll use blue on purpose, okay? I guess I should have used black for those other calculations. Anyways, so we'll treat the science posters like one group. I'll even write that down. Okay, and then move them around. So, what I am saying is, since the 3 science posters have to be together, what if I just called it the group psi? This means all 3 posters put together, right? Okay. So I could have them here in the middle, I could have them first, and so on. All kinds of arrangements. However, within that science group of the 3 science posters, you could arrange those posters. Well, let's think. Just the science. You could arrange those 6 ways. Why? You got 4. What did I say? Yeah, 4, 3. 3 posters to choose from for the first one, 2, and then 1. 6 ways. That's 6 ways for the signs to arrange signs. And you can play around with S1, 2, and 3 if you want to prove that. Now, whatever we do, any arrangement we have, this, say this particular arrangement, we could multiply it by 6 because within that, we could change the order of the posters for the science posters without changing the French or the math. So we're going to multiply any answer we get by 6. So now let's just try this out then. If we're treating the science posters as a group, I'm going to say 6 times, because any answer we get we can rearrange the science poster 6 ways. So that 6 is not a position, it's just due to the ways you can arrange the science posters. And then, how many choices for the first spot? 4 choices. 3 choices, 2 choices, 1 choice. Now, if it makes you feel better, you can put the times 6 at the back. Mathematically, it's the same thing. Multiplies out. You should be able to work this out without a calculator, but 144 ways to arrange the posters. Oh, gee, it's terrible. And C, the three science posters can't be together. That seems like a big problem. And it is a big problem if you approach it the wrong way, but there's some tricks to this. Now, there's some of these, if you look through the example from the textbook, page 522, and you look at their C, there's two methods to solve a problem. And I'm assuming you have read this, but think of it this way. If there's no restrictions on posters, that would mean that there's 6 posters, 6 times 5 times 4, 3, 2, 1. There are 720 ways to arrange all the posters with no restrictions. It doesn't matter where the science or the math are or anything like that. But we're wondering about the science posters not together. Now, it's stated the 3 science posters. You could have 2 science posters together. All the science posters not together. I should just insert there. 3 science posters not together. That's important because we already have the answer. How many ways can you arrange your posters if you keep the 3 science posters together? That was just done in B, right? So if we subtract that answer, hopefully we've gotten it right, we should have the answer for this. So all 3 posters not together, I'll say it again, all 3 posters not together. Is equal to. That would be the total number of ways, 720, minus the ways to keep all 3 science posters together, the 144 from the previous answer. That's 576 ways to arrange the posters. Okay. As you can guess, I'm going to ask you to pause the video after you read example 5 in the textbook and maybe work some stuff out with your pencil and so on. Jot this down using cases, okay? Now, I'm assuming now that you've paused and you've tried that. So let's use some cases. It's about time. Let's read this and make sure we understand the problem. How many 4-digit numbers can you make from digits 1, 2, 3, 4, 5, 6, 7 if the numbers must be less than 6,000 and no digits are repeated? Let's think about some of these restrictions. Less than 6,000. That means it only starts with dot there. Less than 6,000 means it only starts with 1, 2, 3, 4, or 5. Those are the only ones you can choose from. 5 numbers to choose from for your first. And it's odd numbers. Odd means that implies must end with 1, 3, 5, or 7. I guess I should have put an or here too. But anyways, you only have 4 choices for your ending number. But we got to use cases because no digits are repeated. Let's think this through. Come on in. I'm just recording something, but I won't be long. Okay? You just come in. I'm recording this though, so your bell's going to ring on this recording. You guys keep working on the recording. Case 1. You could start with an odd number. So if you start with 1, 3, or 5, how does that affect? Start with 1, 3, or 5. If you start with 1, 3, or 5, that means you can't.
What day is today? Friday?
You guys, I'm just recording something. That means you will only have 3 digits to choose from for your last digit. No. 3 choices. Now let's just think this through. What do you mean? If I started, for example, with 3. If I started with 3, that means that's no longer eligible to be an entity. So I'd have 3 there. Hey guys, I'm recording, so I'm going to be done real quick, but bear with me. So let's put out our blanks. 1, 2, 3, 4 digit number. 4 choices. So our case is that we start with 1, 3, or 5. So that means we have 3 choices for our first digit. Now, this through. That's what it starts with. By the way, 7 wasn't eligible there because we had to be less than 6,000. Now we can choose from all the others, but let's not move to the second digit. Let's move to the last digit. I'll use blue for that. We've already established this is the last digit. It's odd, right? We already said that. There's only 3 choices for that. Now, out of the pool of the digits 1 through 7, you are now down to 5 numbers eligible for the middle. Okay? For the middle digits, like I said, you've used up 1 for the front, 1 for the back, so you've got 5 choices left and 4 choices. When you multiply that, you're going to have 180 ways for the first case. Now, case 1 is it starts with an odd digit, 1, 3, or 5. Or what about case 2? Don't worry, guys, this isn't for you. You guys can start working on it. Obviously, it starts with an even number, but 6 isn't eligible, so it's 2 or 4. Start with 2 or 4. Starting with 2 or 4 doesn't affect the odd digits possible. Yeah, so that means there's 4 odd digits. Now, 4 odd digits to choose from. Hurry up and go soon. To choose from. For last spot. Okay, now let's calculate this out. 4 digits to get through. And the first spot, as we've established, it has to start with a 2 or a 4. So the first spot, there's 2 choices. The last spot is what we should do. And any of the odd digits are available. 4 choices. Now, in the middle, like before, once we've done the outsides, we can say there's 5 choices and 4 choices for the middle digits. When I multiply those up, it's 5 because 2 have already been used, then 3 have been used for this other digit. Okay. That's 160. And this is an OR scenario. To finish this off, 180 ways from case 1 or 160 ways from case 2. So the total is the 2 cases added together. 180 or, so that means add 160. It's 340 ways. You will get further instruction on which questions to do for your teacher or how that happens, okay? Thank you.